Alright guys, welcome to our channel Code with Sunny, and today we will be discussing the stone game fourth, the series of problem from this stone game, and it is categorized as hard problem. I don't know why, but yeah, this is the problem that we are going to do with the help of dynamic programming. And yes, I don't think this problem should be in the hard type, because this is this concept involved in this problem is like quite standard, and you can solve such type of problems, or you can find such type of problems a lot of from this LeetCode problem set also, or you're going to find on some other competitive programming websites. Okay, so this is quite a standard problem. So okay, so we are going to use the dynamic programming approach to solve this one. So Alice and Bob take turns playing a game with Alice starting first. Okay. So initially there are n stones in a pile, and each player's turns the player makes a move consisting of removing any non-zero square number of stones in the pile. If Alice is going to play, then Alice is going to pick up some non-zero square number, and it is going to remove that amount of piles, yeah, that amount of stones from the pile. Okay. Also, if a player cannot make a move, she loses the game, and given a positive integer n, we have to return true if and only if Alice wins the game, otherwise return false, assuming both players is going to play optimally. Okay, so let me pick up an example and we'll explain you how the things are going to be done. Okay, so let's say, yeah, so let me just open my, yeah, so we are going to take some n, let's say n equal to 5. Okay. Yeah, so let me pick up first a color, n equal to 5. Okay, so it means that there are 5 stones in the pile, and we are going to remove one by one, starting from the person Alice, some non-zero square number. Okay, so let me just okay, so Alice is going to start. So what we are going to do is, like, suppose Alice chooses a number called let's say 4. Okay, so you can see 4 is a perfect square. Okay, and there are 5 stones in the pile, so we are going to subtract 4 amount of stones. You are going to have finally 1 stone in our pile. Now Bob is going to come, and Bob is going to choose some non-zero square number of stones from the current amount number of stones present in the current pile. You can see there are only 1 stone present over here, so the Bob has only one choice to pick up the number 1, which is also a perfect square. Okay, so note that we are going to choose a perfect square number. Okay, so perfect square. So if the Bob is going to choose this amount, you can see number of stones, finally number of stones would become 1 minus 1, which should be exactly 0. Now if Alice came and it is going to choose some number of stones from the given pile, you can see since the number of stones has reached to the value equal to 0, Alice cannot make any move. If Alice cannot make any move, then you can see Alice is going to lose this game. Okay, in that case we are going to return false, because if Alice wins the game we are going to return true, otherwise return false. So when n is going to be 5, that Alice is going to lose the game. But you can see this is not the optimal way to calculate the answer. This is not the optimal way to calculate the answer? Because I have chosen in the initial case as 4. Like Alice is going to choose the number which equal to 4, which is a perfect square. Okay, what about Alice is going to choose exactly 1? That is, from 5 stones Alice is going to choose exactly 1 stone. So in that case n will reduce to the value 4. Okay, now when Bob will come out, and Bob will work on n equal to 4. Okay, so in that case Bob will again choose the exactly 4 amount of stones from this one, and n will reach 0. Now Alice will came, and Alice will see that yes, we are not having some stones, so Alice will lose. But here also you can see when n is 4, Bob has two choices. Either Bob will choose exactly 4 stones or exactly 1 stone. If Bob will choose exactly 1 stone, you can see n reaches the value of 3. Now you can see at every step we have a lot of possibilities. Okay, but we can find those possibilities or find that optimal way to reach the answer efficiently with the help of dynamic programming. Okay, so let me draw some recursion tree that will help you to understand. Okay, so let me say n equal to 5. So if n is 5, you can see I can choose 1, I can choose 4. Okay, now if at this point I can choose 1 and it becomes 0. Let me write down over here. I am choosing 4 and I am choosing 1. Okay, at this point we are going to have the value 4. Now what about if you choose the value 1? If you choose the value 1, we are having the 3 value, and if we choose the value 4, we are having the 0 value, right? And again you can see at this 3 position, if we are choosing the value 1, we are going to have the value 2, and if we are choosing the value, no, we cannot choose any other value. Now again 2, if we are choosing the value 1, we are left with 1, and at this one we are finally left with 0 value. Okay, and if you choose the value 1, now you can see these are the ways from which we can move from one number to another number, and each level you can see the players are going to change. Alice will choose, then Bob will choose, and so on. But at the step for n equal to 5, we need to find which player will win for n equal to 5, which player will win. Now if you focus over one thing, that Alice will always start the game. Where is Alice? Yes, Alice is starting the first. Okay, so if Alice will always start the game, both the players are playing optimally, right? So if Alice will start the game, and if at the next level, that is, you can see at the level where n becomes 1 and n becomes 4, if Bob will win the game at this position, let's say Bob will win the game at this position, or Bob will win the game at any of these positions. Let's say Bob will win the game at this position, and here Alice will win the game. Okay, so if in the next step Bob will win the game, then what Alice is going to do? Alice is going to choose the value 4 and make n decrease to 1, so that Bob will win the game at the next position. So that current for the current level, that is for n equal to 5, Alice will always win the game. Okay, so that is the steps that we are going to do. So let us pick an example. Again, let's say where Alice will win the game. Okay, so for n equal to 4, it is saying that true. Okay, so n is 4. So I will draw a tree where I can choose 1, so the value would become 3, and if I will choose 4, so the value would become 0. So you can see we want Alice to win the game at this position. So for the next level, that is for n equal to 3 and n equal to 0, Bob must win this game. Bob must win this game. You can see at 0, for exactly 0 number of stones, Bob will win the game, right? Because there are no stones present in the pile, and Alice is going to start first, and there are no stones, Alice will lose, so Bob will win the game for n equal to 0. So for n equal to 4, what Alice is going to do is, like, Alice will choose exactly 4 stones from the given number of given piles of stones. So the number of stones will reduce to 0, and that is n becomes 0, and n equal to 0, Bob will win the game. So for n equal to 4, Alice will win the game. So this is the entire concept, and we are going to do that by using a simple linear DP array, which will help us. So we will start with n equal to 0. It should be like this one. Let me take some of the examples. N equal to 0, n equal to 1, n equal to 2, n equal to 3, n equal to 4, and let's say we have some another n equal to 5. Okay, so what we are going to do at this position, you can see for n equal to 0, Bob will win the game, right? And for n equal to 1, either like we want Alice to win the game, because Alice is starting first, so Alice will perform the move such that he always win the game. Okay, so n equal to 1, Alice will choose exactly 1 stone, so n becomes 0. So if n becomes 0, Bob will win the game at this position. So it means that for n equal to 1, Alice will win the game. So at n equal to 1, Alice will win the game. Okay, let's talk about n equal to 2. So there is only one possibility, choose 1 stone, so n becomes 1. So at n equal to 1, Alice will win the game. But and for n equal to 2, we want that Alice will win the game for n equal to 2. So for Alice to win the game at n equal to 2, for the next level, that is, you can see there are only one elements present in the next level, that is for n equal to 1. There doesn't exist any n for which Bob will win the game. that is for n equal to 1 we have Alice will win the game. So if Alice will win the game for n equal to 1, so for n equal to 2 Bob will win the game. So we are going to write Bob. So let's take a example. If n equal to 2, so there is only one possibility that Alice will choose, that is the number 1. So n becomes 1. So if n becomes 1, so the turn is for the Bob right now. So Bob will choose the number 1. So n becomes 0. So Alice will come and try to choose some of the stones, but the number of stones is exactly 0. In that case, Alice will lose the game. Obviously, you can see n equal to 2, Bob will win the game. So let's talk about n equal to 3. So Alice will try to win the game for n equal to 3. So he will choose the number 1. So n becomes 2. So if n equal to 2, if there exists any element at the next level, that is for n equal to 2, if Bob will win the game, Alice will win the game for n equal to 3. So you can see, yes, n equal to 2 has the Bob, so it will make the n equal to 3 for Alice. Okay, so let's talk about n equal to 4. Here the concept will become much more clearer. So there are two possibilities. If Alice will choose 1 or Alice will choose 4. So if Alice will choose 1, so n becomes 3, and if Alice will choose 4, n becomes 0. Now you can see at the next level there are two possibilities. If any of the possibilities will give that Bob will win the games, then Alice will win the game for n equal to 4 also. Okay, so let's search about n equal to 3 and n equal to 0. You can see n equal to 3 says that Alice will win the game. N equal to 0 says that Bob will win the game. So Alice will choose exactly 4 amount of stones. So it makes n as 0. So if n becomes 0, Bob will win the game. So if Bob will win the game for n equal to 0, Alice will always win the game for n equal to 4. Okay, so Alice will choose 4 amount of stones for n equal to 4. It will make Alice to win for the current state. Okay, so whenever you are trying to fill the value for the current state, you will search for the next state by choosing some perfect square number. And if at any of the positions, if the Bob is going to win the game, that will make Alice to win for the current state. Okay, you can see for n equal to 0, Bob will win the game. So for the current state, Alice will win the game. So for let's talk about n equal to 5. So we have two possibilities. Choose 1, so n becomes 4. Choose 4, n becomes exactly 1. So let's search for n equal to 4 and n equal to 1. N equal to 4 says Alice will win the game. N equal to 1 says Alice will win the game. Okay, so if Alice will win the game for the next levels, for all those next levels, so there is no possibility that Alice will win the game for the current level also. In that case, Bob will win the game for n equal to 5. Okay, so here is what we are going to fill the DP array. So let's look over the code and we'll try to understand how we are going to frame out the steps. Okay, so we'll have a linear DP array, and 0 will denote Bob will win and 1 will denote Alice will win. Okay, so I will start with the position 1. So I will try to pick up every perfect square number less than equal to I. So I will try to remove that amount of stones, and at any next level, that is if I'm talking about the level current level, which includes the n equal to I number, then for the next level, if we'll choose j into j amount of stones, the next level would be like I minus j into j. You can see this number, I minus j into j. So this is our next level, and if at that level Bob will win, that is dp of this value would become 0, then for the current level Alice will always win, because there exists a state where Bob will win for the next level. So dp of I becomes 2, and we are going to break because we have found the value. Otherwise, this you can see dp of I would remain 0, which would denote that Bob will win for the current state. Finally, we want to return what will happen if n stones are in the pile. That is why we have returned dp of n. You can see over here. Okay. So if you guys still have any doubts, you can mention in the comment section of the video. And don't forget to like my videos, share my videos, and subscribe it. Thank you for watching this video.